Namaste dear children, I am Rekha. Welcome to my channel Rekha's Knowledge Hub. Today we will see NCERT Class 6 Maths Chapter 5 Prime Time Part 3. Co-prime numbers for safekeeping treasures. Which pairs are safe? Let us go back to the treasure finding game. This time treasures are kept on two numbers. Jambi gets the treasures only if he is able to reach both the numbers with the same jump size. There is also a new rule. A jump size of 1 is not allowed. So now we can go back to the treasure finding game. This time, Grumpy kept the treasures on two numbers. Jumpy, he will get the treasure only if he is able to reach both the numbers with the same jump size. There is also a new rule. A jump size of 1 is not allowed in this game. Where should Grumpy place the treasure so that Jumpy cannot reach both the treasures? So, Grumpy should place the treasures in such a way that Jumpy cannot reach both the treasures. Will placing the treasures on 12 and 26 work? Does it work? No. Why? If the jump size is chosen to be 2, then Jumpy will reach both 12 and 26. So, if the treasures are kept on 12 and 26, then Jumpy can easily find it out. Why? Because if he choose jump size as 2, then he can easily reach both 12 and 26. What about 4 and 9? Jumpy cannot reach both using any jump size other than 1. So, Grumpy knows that the pair 4 and 9 is safe. 4 and 9 is a safe pair. Why? Because Jumpy, he cannot reach both numbers 4 and 9 with the same jump size other than 1. So, what is special about safe pairs? They don't have any common factor other than 1. They have only one common factor, that is 1. They don't have any common factor other than 1. They are called safe pairs. Two numbers are said to be co-prime to each other if they have no common factors other than 1. So, these numbers are called co-prime numbers because they have no common factors other than 1. They have only one common factor, that is 1. Check if these pairs are safe. We will do. Check if these pairs are safe. First one, 15 and 39. Factors of 15, 1, 3, 5, 15. Factors of 39, 1, 3, 13, 39. Common factors 1 and 3. So, this pair is not safe. Why? Because they are not co-prime. They have common factor other than 1. See here, they have a common factor 3 other than 1. So, this pair is not safe. Then next one, 4 and 15. Factors of 4, 1, 2, 4. Factors of 15, 1, 3, 5, 15. Common factors 1. So, this pair is safe because they are co-prime. 1 is the only common factor. Next pair, 18 and 29. Factors of 18, 1, 2, 3, 6, 9 and 18. Factors of 29, 1 and 29. Since 29 is a prime number, its only factors are 1 and itself. Common factors only 1. So, is this pair safe? Yes, this pair is safe because they are co-prime. 1 is the only common factor. Next pair is 20 and 55. Factors of 20, 1, 2, 4, 5, 10, 20. Factors of 55, 1, 5, 11, 55. Common factors 1 and 5. Is this pair safe? No. Why? Because they are not co-prime. They have common factor other than 1. They have a common factor 5 other than 1. So this is not safe. Which of the following pairs of numbers are co-prime? First pair 18 and 35. Factors of 18 1, 2, 3, 6, 9, 18. Factors of 35 1, 5, 7, 35. Common factor is 1. So this is co-prime because no common factor other than 1. There is only one common factor 1. So this is co-prime. Next pair 15 and 37. Factors of 15 1, 3, 5, 15. Factors of 37 1, 37. 37 is a prime number. So only two factors 1 and the number itself. Common factor is 1. So this is co-prime because no common factor other than 1. Next pair 30 and 415. The factors of 30 are 1, 2, 3, 5, 6, 10, 15 and 30. Factors of 415 are 1, 5, 83 and 415. Common factors 1 and 5. So this is not co-prime because there is a common factor other than 1. There is a common factor 5 other than 1. So not co-prime. Next one 17 and 69. The factors of 17 are 1 and 17. Factors of 69 are 1, 3, 23 and 69. Common factor 1. So this is co-prime because no common factor other than 1. Next pair 81 and 18. The factors of 81 1, 3, 9, 27, 81. Factors of 18 1, 2, 3, 6, 9, 18. Common factors 1, 3, 9. So not co-prime because there are common factors other than 1. Common factors other than 1 here 3 and 9. While playing the Idli Vada game with the different number pairs, Anshu observed something interesting. Sometimes the first common multiple was the same as the product of the two numbers. At other times, the first common multiple was less than the product of the two numbers. Find examples for each of the above. How is it related to the number pair being co-prime? So, while playing the Idli Vada game, Anshu, she observed something interesting. Sometimes the first common multiple was the same as the product of two numbers. Sometimes the first common multiple was less than the product of two numbers. We will see some examples. Sometimes the first common multiple was the same as the product of two numbers. For example, 3 and 5. Multiples of 3, 3, 6, 9, 12, 15, etc. Multiples of 5, 5, 10, 15, 20, etc. First common multiple is 15. So, this 15 is same as the product of the numbers 3 and 5. 3 into 5 is 15. So, here the first common multiple is same as the product of two numbers. This occurs when the two numbers are co-prime. Their only common factor is 1. Then second case. At other times, the first common multiple was less than the product of two numbers. For example, 4 and 6. Multiples of 4, 4, 8, 12, 16, 20, 24, etc. Multiples of 6, 6, 12, 18, 24, 30, 36, etc. First common multiple is 12. So here the first common multiple is less than the product of two numbers. What is the product of two numbers? 4 and 6. It is 24. 12 is less than 24. So this occurs when the two numbers are not co-prime. The first common multiple is less than the product of two numbers because the numbers share common factors other than 1. Now you can see an interesting topic, co-prime art. Observe the following thread art. The first diagram has 12 pegs and the thread is tied to every fourth peg. We say that the thread gap is 4. See the first picture. It has 12 pegs and the thread gap is 4. That means the thread is tied to every fourth peg. So you just start from 12. Then the thread gap is 4. That means you need 4 jumps. 1, 2, 3, 4. Then you reach 4. Join 12 and 4. So the thread is tied to 4. Then again thread gap is 4. So 4 jumps needed. 1, 2, 3, 4. Now you reach 8. Join the points. Then again 4 jumps. So 1, 2, 3, 4. You reach 12. Join the points. Now you reach the starting point itself. Now you can stop. The second diagram has 13 pegs. See here. There are 13 pegs and the thread gap is 3. That means the thread is tied to every third peg. What about the other diagrams? Observe the pictures, share and discuss your findings in class. See this picture, the third one. How many pegs are there? There are 16 pegs. And here the thread gap is 6. That means the thread is tied to every sixth peg. You start from 16. The thread gap is 6. So you need 6 jumps. 1, 2, 3, 4, 5, 6. Then you can join the points like this. Then from 6 again you need 6 jumps. So 1, 2, 3, 4, 5, 6. Now you reach 12. So join the points. Then from 12 again 6 jumps. 1, 2, 3, 4, 5, 6. Now you reach 2. Join 12 and 2. You continue this process. Finally, you can see that the thread is not attached to all pegs. See here, thread is not attached to 1. It is not attached to 3, 5, 7, 9, 11, then 13, 15. So, the thread is not attached to all pegs. See the factors of 16. The factors of 16 are 1, 2, 4, 8 and 16. Then factors of 6, 1, 2, 3, 6. Here 16 is the number of pegs and 6 is the thread gap. Then what about their common factors 1 and 2? So this is not co-prime. See the next figure. See the second figure. How many pegs are there? 13 pegs are there. And here the thread gap is 3. That is, the thread is tied to every third peg. Okay. In this picture, you can see the thread is attached to all pegs. What are the factors of 13? 1, 13. Factors of 3, 1, 3. Common factors? Only one common factor, that is 1. So this pair is co-prime because there is only one common factor, that is 1. No other common factors. In some diagrams, the thread is tied to every peg. In some, it is not. Is it related to the two numbers, the number of pegs and the thread gap being co-prime? The thread will pass through every peg when the two numbers are co-prime. Here the two numbers are the number of gaps and the thread gap. So, the thread will pass through every peg when the two numbers are co-prime. The thread will not pass through some pegs when the numbers are not co-prime. So, this is the relation we got from the above figures. Make such pictures for the following. 15 pegs, thread gap of 10. You draw a circle with the 15 pegs. Then here the thread gap is 10. You start from 15. Then count 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here the thread gap is 10. So join 15 and 10 like this. Then from 10 again count 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So join to 5. 10 and 5 you join. Okay. Next from 5 you count 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So join 5 and 15. So now you reach the starting point. Then you can stop here. See the next figure. 10 pegs, thread gap of 7. So you can draw a circle like this with the 10 pegs. Here the thread gap is 7. So you start from 10 and count 7. 1, 2, 3, 4, 5, 6, 7. Then you can join 1 and 7. Sorry, 10 and 7. Then from 7 again count 7. So after 7, 1, 2, 3, 4, 5, 6, 7. So join 7 and 4. Then from 4 again count 7. So after 4, 1, 2, 3, 4, 5, 6, 7. So join 4 and 1. Then from 1 you count 7. So 1, 2, 3, 4, 5, 6, 7. So join 1 and 8. Then from 8 again count 7. So 1, 2, 3, 4, 5, 6, 7. Join 8 and 5. Similarly, you can complete the diagram. Next you join 5 and 2. Then you join 2 and 9. Then 9 and 6. Then 6 and 3. 3 and 10. Now you reach the starting point. Stop here. See, in the first case, the thread is not tied to every peg, but in the second case, the thread is tied to every peg. See the next figure. Here there are 14 pegs and the thread gap is 6. You start from 14. Then after 6 gaps, you will reach 6. Then from 6, you reach 12. From 12, you will reach 4. Then from 4, you will reach 10. From 10, you can reach 2. Then from 2, you can reach 8. From 8, you will reach 14. See, you reach the starting point, you can stop here. See, in this picture, the thread is not tied to every peg. See the next one, 8 pegs and thread gap of 3. See this figure, there are 8 pegs and the thread gap is 3. So you start from 8. Then after 3 gaps, you will reach 3. From 8, 1, 2, 3. So you will reach 3 because the thread gap is 3. Then from 3, you will reach 6. From 6, you will reach 1. From 1, you will reach 4. From 4, you will reach 7. From 7, you will reach 2. Then from 2, you will reach 5. Then after 5, you will reach 8. So you reach the starting point, and in this case, the thread is tied to every peg. Children, thanks for watching. If you like this video, please like, share and subscribe. We will see you in the next video. Thank you. The playlist for all the chapters are given in the description box. Kindly go through it. Thank you.